Hello everyone, welcome to today's LeetCode problem of the day. Today's problem is sum of root to leaf binary numbers. So we are being given a root of a binary tree where each node has a value 0 or 1. Each root to leaf path represents a binary number starting with the most significant bit. Okay. For example, if the path is 0 1 1 0 1, then this could represent 0 1 1 0 1 in binary, which is 13. Now you have to return the sum of all these numbers. Now what it means that let's try to understand with an example. So the root to leaf path is 1 0 0, which is 4. Then one more 1 0 1, which is 5. Then 1 1 0, which is 6, and 1 1 1, which is 7. And sum of all this number is 22, and that is what we have to return it. So this problem is like help us to understand two things. One is traversal of binary tree, and the second one is how to convert binary to decimal as we traverse. Okay, now traversal of binary tree is easy. So we just have to use DFS. We just have to go left, then we have to go right. Now how we can convert binary to decimal as we like traverse the tree. Okay, now see this. We have to get some bit knowledge. So we encounter 1. Okay, we write 1. So this is the binary representation. Now when we traverse to the next node, so that means 1 and 0, 1 0. So 1 has been shifted to the left. So this is left shifting, right? So when we do left shifting, the number gets multiplied by 2. Okay, see this one is 1, and 1 0 represents 2. So that means from this to here it gets multiplied by 2. Now again see, when we do left shifting again, so it becomes 1 0 0. And what is this number? This one is 4. So that means from here to here it gets multiplied by 4 again. It gets multiplied by 2 again. Same things happen when we do right shifting. It's get divided by 2. So when we do right shifting, so 1 0 0 becomes 1 0, right? And what it represents? It represents 2. That means 4 by 2. And when we do left shifting, it gets multiplied by 2. So this is the logic that we will use when we traverse it. So we will use DFS, that means recursion. So we will need a helper function. So let's write it: private int helper. It will take the node and it will take a variable, let's say current. Okay, now if root is null, then just return 0. Okay, if root dot left is null and root dot right is also null, that means we have encountered a leaf node. So that means return what? Current into 2. Okay, what we can do is we can create a variable here. Let's say okay, so current will be current into 2 plus root dot val. Okay, so if we encountered a leaf node, then just return it, else return helper root dot left current plus helper root dot right current. Cool. So this is the logic. Now we will use helper root, and what will be the first from where we will start? We will start from 0, because every binary starts from 0. So 0, let's do some dry run. So we come here, so the root is not null, so current becomes 0 into 2, that means 0 plus root dot val, so it becomes 1. All right, now root dot left is not null, so this condition becomes false. Now it goes to root dot left. Now we are in this node. So when we are in this node, so current is 1 into 2, that means 2 plus 0, which is again 2. All right. Now now again this is not null, so we now we again go root dot left. Now we are in this node. Now what is the current? 2. Now again current into 2, which is 4, plus root dot val, which is 0. Now root dot left is null and root dot right is also null, so therefore we return current. So it becomes, so it returns this one 4. It returns 4. Okay, now when we are in this like now we comes to in this node again. Now we are traversing right. Now what was this? Now till here it was 2, right? It was 2. So when it comes to this node, it becomes 2 into 2 plus root dot val, which is plus 1, which is 5, right? So and it is a leaf node, so it returns current. So 4 plus 5, 9. So till here it returns 9. Now in the same case, it will go towards the right and return the same thing. So this is the solution. Let's try to run it. Okay, it's getting accepted. Let's try to submit it. Accepted. Okay, so as you can see, it took 0 millisecond. It is the optimized code. We are traversing the binary tree and creating the like decimal. So the time complexity is big O of n is the number of nodes, and the space complexity is only big O of 1. It's constant because we are not taking any extra space. So thank you, keep practicing, and see you tomorrow on another POTD.